a big stage. And then it's another thing to be announced. But if they then play a movie with Indiana Jones-like music before you actually get to start, that's scary. Who has been to Bulgaria PHP before? Okay, so I was here in 2015, has been quite a while since then. It was an amazing event even back then, and when they kind of said that they're going to bring it back, I was very, very eager to be part of this again. And I'm involved in conferences for a long time in various roles as a speaker, as a co-organizer, as advisory board, whatever. I know how much effort it is, and they make it sound so easy, so I can tell you the true rock stars in this building today are the organizers, so please put your hands together and give a big applause to all of them. So I am a consultant, I'm a trainer, I'm a coach, sometimes do a lecture at university, and I'm not going to talk about me too much. This is my company, you can find all that on the internet. If after all of this you're still up to talking to me, I'll be here all weekend, and if you feel like your company or you might be interested in working with us, then just drop us a mail. And that's all the advertisement you're going to get. I, in fact, used to make the joke that I'm a scalability expert because I'm father of twins. But my twins are so old now, they are 9. And nowadays it's like, Dad, can you please leave? We got stuff to do. So I actually get to play my electric guitar again every once in a while. And I thought with all that rock star stuff, I wasn't sure whether I wanted to try this. And like, you know, when I was young, I used to play in a band, maybe to 30 to 50 people at max. And it still kind of felt like a rock star. So I was considering to make this a rock star moment for all of you and Bulgaria PHP and Bulgaria at large. But I'm not sure, since they are taping, whether we're going to run into trouble being sued by Deep Purple if we kind of try and give that a shot. Or do you insist? We do insist. You do insist? Okay, so I'm going to make us all a group now, which is in fact very important. So we're going to split the room, and you guys, you are going to give me a smoke, okay, on a count to 4. So we'll practice once. 1, 2, 3, 4. That was honestly ridiculous. So let's do it again. 1, 2, 3, 4. Okay, and you guys, on the water, on 4 for the first try. 1, 2, 3, 4. Okay, let's put this together. You guys do smoke. 1, 2, 3, 4. And then it goes the fire in the sky. This is actually the British Parliament. No, not what you think. I'm not making a Brexit joke on camera. I might do one on Donald Trump later, but... So this actually happened in 1834 when they accidentally burned down the Parliament. Why did that happen? Well, because they burned all the tally sticks they had used over years as basically a currency. And they had stopped using them in, I think, 1826, and then they had them lying around for a couple of years. And in 1834, ultimately, they decided that they would burn them. And they burned them all at the same time, which set the whole building on fire. That's a true story. And it clearly tells us that they shouldn't have done that. They should have recycled the wood. And it would also have been a lot better for their CO2 balance, obviously. So those are these tally sticks. Sorry, let's move the mouse pointer out of the way. And the idea is that you can put it in half, you make marks, and then put it in half, And if they fit together, then you know, well, that's the other person that I'm in debt with. And that was actually used as a monetary replacement or as a means of money for a very, very long time. If you didn't know about that, I didn't know about that either until a few days ago, where I find out. And that kind of got replaced by a ledger. It originally existed because people couldn't really read and write. And still the interesting thing is that it was in fact a distributed ledger, right? Because there was no central ledger that was written. So it was in fact a blockchain, an analog implementation of blockchain, right? So we're going to talk a little bit about monolithic blockchain today. And that's all the buzzword bingo I'm going to give you. We're going to show some code examples. They are simplified and not production ready, so please don't copy and paste them and yell at me. They will not work as they are because you're probably not using PHP 7.4. And I'm really happy about that. This is PHP 7.4 style code, and that might be a typical product entity in some e-commerce type of setup with a bunch of attributes, and I'm even only showing attributes and only showing part of that. It might look like something like that. So it's usually a pretty huge class. Well, I've seen them up to 10, 20,000 lines of code, but that's rare edge cases, I have to admit. Usually people are fine with 2,000. So a controller to work with that might look something like that. So it's executing and mapping an HTTP request to a call of a so-called use case. I'll call it a use case. I don't like the term service too much because it's overloaded. And this is my use case adding a product to the cart. So we're going to receive the IDs, and then we use a cart repository to retrieve a cart, put the product in the cart, and save the cart. So that's pretty straightforward, and everybody has more or less seen stuff like that. And at first glance, it might look like, well, that's actually good code. It looks like up to standards, rather modern. Maybe there is even tests. Yeah? Let's talk about CQRS, and then let's think about how could we improve that whole thing. So CQRS is, and this is an introductory talk about those concepts. If you're already familiar with the stuff, the only takeaways you're going to have are my jokes. And since I'm a German, I don't have a sense of humor, so jokes are a problem. CQRS is command query responsibility segregation. That's a very long term, which goes back to a command query separation as described by one Bertrand Meyer. And if you look at that's the actual book cover of the second edition, it says the most comprehensive OO reference ever. That's true. A tour de force, that's also true because that guy is a mathematician and he writes books like mathematicians writes books. It's not fun to read, but it contains all the wisdom that you ever need to know about object-oriented development. And then you can tell it's really old because they included a CD-ROM. I don't know what the fuck that is. Probably a successor to Tally Sticks. So what Bertrand said is every method should either be a command that performs an action or a query that returns data. Well, that resonates. That sounds kind of familiar. Don't we have that setters versus getters thing, which is a very, very basics thing that everybody gets taught when it comes to OOP, pretty much on day one. I'm not going to argue about the question whether setters should be there, but it's about the diversion between the dividing of responsibilities between those twos. So let's call them mutators and getters. I like mutators more because if you look at something like that, that's a typical setter, setting the price of a product. That's still, well, I can kind of relate to that, but I would like this more. Maybe we'd apply a discount, and maybe discount is an object of its own, and discount knows that it's going to be valid for like a week, so it automatically brings back the price, and we don't have to call set price again in 1 week, which actually poses a lot of responsibility on developers or personnel working the system. So I like mutators more than setters, but again, it's not about that in this talk. And of course, we are violating those principles on a regular basis, because this is, well, yeah, it's kind of retrieving data, but it's also changing state, right? So not everything works exactly like that, but it's actually very, very helpful to think in terms of that separation. And we also have that separation in HTTP, don't we? I mean, what does get do? No, what does post do? That may be a better question to ask first. What does post do? It causes side effects. So it's a state change. What does get do? It retrieves data. It's idempotent. You can call it as many times as you like. It's not going to change server state. It doesn't have any side effects. That's why caching works on the web. Because get is not really doing anything, it's just retrieving information. And that's ubiquitous. We build applications based on HTTP. Probably everybody in the room does, or at least has done at some point. So that's pretty ubiquitous, and getters and setters are pretty ubiquitous. So why do we build applications that do not care about the separation of commands and queries, of reading and writing? And CQRS is exactly that. It takes the CQRS principle to the application design level, if you want, to a bigger scope. So a command changes the state of a system, but it does not return a value. Void is your friend. If you can't use void, you're using an outdated version of PHP, and it's high time to upgrade. I think void is in 7.1, and I think 7.1 is already not in supported, it's unsupported, right? End of the month. Yeah, well. So you have until the end of the month, and then I will be calling you a bad person. So queries do not change the observable state of the system. What's observable? Well, observable state means if there are any accessors to retrieve the state, because technically, let's face it, every GET request you send to a server somehow changes server state, not in a significant way for the domain, but you're probably going to log the requests. You might set a session, initialize a session, something like that. So there is some state changes, but that's usually not part of the API of your application, and that's what observable state means. If you cannot see it at the application level, then it doesn't count as a state change. Obviously, it returns a result, and caching and logging are typical examples for actual small little state changes that happen kind of behind the scenes, but they do not change the server state at a domain level. At least they shouldn't. So let's look at some code. We have a cart, and that cart, a product gets added to that cart. That looks normal, doesn't it? But then again, product, wasn't that couple of thousand lines monster? Isn't that a big object? Yeah, it is. So I came up with just a few methods that might be part of product, and there is a shitload more. And they are very, very different things, and you can do a lot of things. So if you have a type declaration product here, you're actually coupling your cart to something that's very complex. If we dive into solid principles, everybody should have heard of solid, and most people think they are really familiar with solid, but when it comes to applying solid, people sometimes fall a little short. So interface segregation, the I in solid, tells us that clients should not depend upon interfaces they do not use. What does that mean? Is the cart going to move the product to another category? Probably not. But by declaring it there, we're kind of relying on that API. So we're relying on a big API. And interface segregation tells us that we shouldn't. And there's another solid principle that's violated, that's single responsibility. There should be only one reason to change a class. Well, if a class does 10 things, if a class serves 10 different use cases, then we have 10 different reasons at least to change that class. That's more than one. And what solid tells us is if we're violating solid principles, we have a maintenance problem. It's not like killing you immediately, it's not going to be painful on the day you do it, but on the long run, you will put in more maintenance effort, you will see more regressions as you make changes to the code. So even in that simple and seemingly trivial example, we're already seeing that, well, those big classes may be not the best design choice. What if we could define an interface buyable because the card just needs a kind of identifier, maybe a stock keeping unit, and it needs to get the price because obviously the card needs to do some calculation or needs to, enable the checkout to do some calculation because people actually want to know how much they are supposed to pay before they click on buy. And we should make the card depend on a small interface like buyable. Now you're saying, well, that's easy. We can make product implement buyable, and then we can type hint buyable instead of product. But that really doesn't change the fact that product is still a big object. So can't we do better? Let's look at a caching example. And I think there will be a FIG discussion later today. They are going to enjoy discussing this, which is, well, this is what a caching interface might look like. What is if we apply CQRS ideas here? What if we separate reading and writing? We end up with two interfaces. That doesn't really hurt. We can still use the same code. Now implements two interfaces. But now, since we have this, we can take the next step and split the implementation into two different objects. Think about something that accesses the database. If at your application level, whenever you serve a GET request, you have just an API to read from the database, that in turn would mean that your application can work with a database user that has only read rights, only credentials that allow them to read from the database. What's the likelihood of somebody changing data, maybe through a SQL injection? Yeah, it's 0, because they can't write to the database. So actually, also from a security perspective, this separation makes a lot of sense. And, well, in one request, you usually do some thinking and pondering and calculating, or you're delivering content. We have the post redirect get pattern on the web, so post requests send forms, and sometimes we just redirect, browser does a get, so retrieves another page. There is a very, very clear separation that's easily possible at the protocol level. Why are we not making use of that at the application design level? We should do that. So we end up with multiple models. Multiple models have a few very, very big advantages. Number one, we end up with smaller objects. Well, that's what all the reuse is about. Big objects means if you reuse, it's never going to be exactly what you need, so you're going to end up being copy and pasting. You can only reuse small code blocks, because that's the only way how you can sort of pick, I want to use that one and not that one, and I'm going to replace that one by another one. So that's the notion of rather building one big object, build a lot of small objects. Favor composition over inheritance. We have single-purpose objects. Since we are building one model for one use case, we are more solid now. And that means, let's assume we have 10 use cases and we build 10 read models or write models, depending on what the use case is. So we build 10 different models. Yeah, there will be some overlap, but that doesn't hurt, because the overlap is not actual code duplication, it's serving the purpose, serving the use case. So if the use cases evolve differently, what seemed like duplication suddenly is not duplication anymore, because the objects diverge. So it doesn't hurt to go with a little quote-unquote duplication if it feels like that. It's only duplication if the intent of the code is the same. So if we do that, what is the likelihood of breaking use case number 1 as you work on use case number 2? Well, it's pretty much 0 because it's different code. How could you possibly break existing code by not touching it? I mean, okay, there are ways, but you get the idea, right? So by creating more objects that are simpler and smaller and more straightforward and more to the point, more catered to the use case, we will not spend more development effort, but it will in fact become easier because those objects are far easier to manage. And the most important part is, if you build one use case, you don't have to think about the other ones. And let's face it, that's one of the things that's slowing us down as developers. We are working on one use case and somebody says, yeah, but there is that other use case and that's going to cause a problem here. So we have to take into account that we have to do weird things here because there may be that other use case tomorrow, next year, at some point in the future, or not. And all that is unnecessary because it's unproductive. So I want to be focusing solely on building this one use case, and I'm going to build very specific software for that exact use case. And this is what CQRS really is about. Build separate software for each use case. Let's look at an example. That's our product, kind of broken down into 2 different product objects. The first one is the one that the card would use. And I'm only showing the attributes, not even the methods, you get the idea. And the other one would be a product for display. Let's face it, why do we have those fat objects with those fat ORMs that load like a 2 or 3 digit number of attributes and stuff them into one object instance? Because somebody somewhere displays some of those attributes. So we are building those gigantic objects with a lot of data that actually the decision making doesn't need, because the checkout doesn't care about the size and the color of the product. It's just, okay, I can sell it to you at this price. That's what the checkout cares about. And all the other stuff is there because somebody displays it somewhere, maybe even not. And CQRS is about separating that. So we are suddenly losing the data focus. We are not thinking about our object as a container of data, but we are thinking about our object as something that has behavior, that implements a use case. If you have heard about BDD, behavior-driven development, that's pretty much along those lines. That's the way of thinking. Do not focus on the state of the object, focus on the behavior. That also heavily affects the way you write tests once you get started with that, or further down the road with it. So we can take it to the next level. What if we make the commands and queries explicit in the code? Let's see. So this would be an update cart command. And I've actually simplified that. That's actual code from a project that we did, from our own checkout that we use. And I have a selection object there. And the selection basically is everything that's on the cart, because the client knows the whole cart. So rather than sending back and forth all those small, add this to the cart, remove that from the cart, and increase the amount from this from the cart, which basically is a shitload of work to do, I'm just saying, well, whenever the client has updated the cart, it's going to send the full cart to the server and says, this is my state of the cart. So I'm avoiding a huge amount of problems by design, and it's less cruddy. It's more along the lines of, okay, I'm updating the cart, this is my selection of products. I really don't care whether a specific product has been there before or not, because we're going to recalculate the cart anyway. And this command, this is a pure DTO, a data transfer object. So whatever they told you about OOP would be, well, this is just a data object, and data objects kind of have a bad smell to them because they are not a best practice. In that case, it's completely okay to do it that way, because we have a DTO that's initialized through the constructor. It's self-validating, so you cannot have invalid data. You cannot create a command if the selection is not there or invalid. You cannot create the command in the first place. So if you have that strictness up front, you will save on a lot of validation later as you work through your use cases. And obviously they are immutable. If you look at the objects, it's initialized through the constructor. It has some getters, and of course it has no setters. Why would you want to change this? You're using it to move data from A to B, and you're not supposed to change the data on that journey. Why would you? Okay, so that's our DTO there. And it has getters, yeah, I mentioned that. And this is the handler for the command. So that's the piece of code that kind of processes the specific request. So there is our repository again. We're updating the cart with the selection and we're saving. It doesn't look really very different, but now we have made the commands explicit. I guess most, and many frameworks do that nowadays, because they basically have realized, and that's another way of looking at that, hey, it's cool to have an abstraction layer between HTTP and our actual code, because in former times, a few bad people, none of them live in this country, but they have passed the HTTP into the domain and basically created a level of coupling that is undesirable. Some people would call it stupid. So let's take this whole thing even further. We were talking about a ledger, right? Let's call this event log. A ledger as in recording transactions, recording stuff that has happened. We can also call that an event log. And an event in this case means something that has happened that is relevant to your domain. And it's basically a fact. It's immutable. You can't change it. And an event log is an append-only store. So we don't have read and write data, but we're only appending. As things happen, we record them, and we're going to write these events to an event log. Let's just assume that we do this. And this is where we go down the route, the event stuff. This is technically very, very separate from CQRS, and we will tie those together. Most people will tell you event sourcing and CQRS are basically the same, and they are very, very close relatives, or they very, if you do one, you do the other. You don't have to. All those CQRS principles I was talking about, you can apply to your existing legacy code base. You just have to start create those small objects. You can even keep the big ones as they are, and you can build new use cases and have your software run the new code to work through the new use cases. You don't even have to refactor. You can write new code and put it in right into your existing code base. Try it out. It's really, it's enlightening, because you suddenly don't have to worry about all the stuff that's already there, because your use case is isolated. You don't care about the rest. So, this is a login handler, and I'm not showing you the command, it's pointless, and it basically does the authentication in some system. And what we're doing here is we are actually violating a rule that I made, right? I said, well, commands don't return anything. In this case, the command returns an event, and you can it's perfectly okay to do it that way. There are other ways of doing that basically disguise the fact. What we're doing here is we are emitting these events. So as we make a business decision, Mr. John Doe is logged in now, we are emitting an access granted event. If Mr. John Doe is not supplying us valid credentials, Magic makes it happen that this event ends in our event log in our event store. Oops, that's... Probably need new batteries. How many slides did I skip? Too many. So, counter increment, that's the interesting method. If I tell the counter to increment itself, I'm actually building state. You could argue that, yeah, well, let's not go there. Yeah, I'm building the state, and then I'm recording a counter incremented event with the actual counter value. So that doesn't look special, does it? Okay. How can we event source a counter? That's the interesting part. We have now created a counter, a new counter. We've incremented it, say, to 5. So we have a bunch of events in our event store, which is counter initialized and 4 counter incremented events, maybe. And if we load them as an array or as a collection, and we iterate through them, well, that takes us exactly to the current state of the world, right? So if you look into your bank account and you figure that you should have €1 million, no, what? Well, €1 million, whatever currency, €1 million in your bank account, and you check with your bank and it says, well, you have like €50 in your bank account. What you usually do in this case is you go to the bank, you say, guys, I've checked my account and it says I have €50 in the account. That's wrong. According to my records, it's $1 million. Can you please change that? And what they'll do is either they'll say, oh, sure, there must be a problem on our side. Let me just fix that by setting the account balance in an aggregate. Or the other way would be like, okay, I don't have a UI for that, but here is our Oracle password. Feel free to log into the database and fix it yourself. And of course, they wouldn't do that. They would tell you, look, like when you opened the account, the balance was 0. And then you put €50 into your account, and that's the last thing that happened. So your balance now is €50. That's event sourcing. That's deriving current state from a sequence of events. And everybody does it. Git does it. MySQL does it. If the tables crash, it goes through a binary log, replays all transactions. It's event sourcing. So let's look at apply. That's the ugly thing, because we don't have method overloading in PHP. Maybe at some point we might have it, now that we have strict typing, at least optionally. This is where we have to write our own dispatch method, because I generically have an apply method that gets called for every event, and then I have to look into those magic strings, what type of event is that, and then I have to call a specific method. And those methods are actually pretty straightforward. They take information from the events and apply them to the state of the counter. Now this happens when I initialize the counter, work with the counter initially, and it works exactly the same way when I reconstitute my counter from the log of events. This is an event-sourced aggregate. It's not scary. You don't need any fancy framework or stuff. It's basically 20 to 50 lines of infrastructure, and I would urge you to dig into that and understand it and actually write it yourself, because it's really educational. And then if you have it, you might consider starting to apply it in your projects. And now we can combine CQRS and event sourcing. Let's go back to the multiple models. What if we need another model? That counter obviously is our business object. It may even make decisions like, I cannot count past 10. If you try to count past 10, I'm going to throw an exception. Okay. What if we want to display a counter? And to make it a little more interesting, I thought about a counter that also displays how many times it was incremented. It's just to add a little touch. So, well, let's use some code that consumes events, like a counter incremented event, takes something that's fancily called a projection, and applies some method, calls some method on the counter to literally apply the event to the projection. Projection is just another object. It's just another model. And we can source that other model from the events just as we did with the original counter. And we are going to end up with something like that. So that's the counter projection. I know it looks pretty similar to the original counter, But remember what I said before about the code duplication. It's not duplication if the intent is different. The one counter was our business logic, and this counter is our display logic. And they may look similar, but they are separate objects. Now I can evolve my business, my display logic completely separate and independent from my actual business logic. Isn't that cool? So, do you want a Donald Trump joke? Okay. You should really look into CQRS and event sourcing and event-driven systems at large, because it's a very, very interesting concept, and there is a lot to it. And even the United States of America have replaced state by messaging. Thank you. So since we are running a little late, and I managed to finish on time, I'm really super happy. If there are any questions, I will be around and then outside, and just feel free to approach me. I will be here all day. We can talk at the party. Thanks again for listening, and I'm going to clear the stage so they can get back on